So sines and cosines. So when we're dealing with sines, yeah.
When you extract it, go over how do we
I'm going to show you. I'm going to show you because once you get the first set of the ordered pairs for your parent function, the shift is just adding or subtracting units of pi or what. And if it's fractional amounts that you have to worry about, it's just using your calculator without pressing the pi button and knowing how to use, excuse me, how to put fractions in your calculator. Whether you use alpha y, is it alpha y equals? Is that how you're switching to a fraction bar? Or you use the math enter button if you have to. So as we're going through these things, remember, when we label this stuff out, we're doing a sine function. What I want to do is I always label my A, my B, my H, and my K. H is your what shift? Horizontal, because it starts with the letter. Exactly. And then the K is your vertical. It's vertical. Very good. Those dumb things you'll never forget. Now, what we're going to be doing with this stuff then, excuse me, is we're going to take a function. Let's say we have y equals, we'll do a negative. Negative 2 sine of 4 x minus 2 plus 1. Let's say we've got that basic function to start. Now, when we start with a basic function like that, the first thing we're going to do, obviously, is list out everything that we can. Our A is negative 2. Our B is 4. Our H is 2. Good, you remember the sign change. And K is 1. So I know that every single one of these points is going to have to shift to the right 2 and go up 1. That's going to be what I'm going to be tacking onto my ordered pair sets. Now let's see what you remember for the amplitude. What's your amplitude here? The A value is negative 2. What's the amplitude then? 2. Very good. Remember, the amplitude is always the absolute value of A. It's 2. Now, what about the period? So it'd be 2 pi over the absolute value. Yeah, so it's pi over 2. Okay. Now, excuse me. Now, in this case here, what we have to do is graph our parent function. Now, I know that a lot of you guys are having problems doing when you have to go through your parent function is in labeling all those breakpoints, all those critical values. So here's what I want. If you're having issues with that, here's a real easy way to remember this. I know I'm going to have to shift everything to the right 2 points, so I'm not going to put my ending period all the way at the end here. I'm going to put it right here. Okay? Now, I know that the period ends at pi over 2. Now, in my brain, that's 1/2. Okay? Does that make sense? It's a half. Here is 0. What's halfway between 0 and a half? A quarter. So this would be pi over 4. I'm just putting pi back into the numerator. What's halfway between 0 and a quarter? 1/8. So it would be pi over 8. Halfway between 1/4 and 1/2 would be 3 pi over 8. Now, if you're not sure how to figure out the halfway point between a fourth and a half, so in your calculators, do 1/4 plus 1/2. Add them together, then divide it by 2. All you're doing is finding the average. This value here is the average of 0 and a fourth. This value here is the average between a fourth and a half. Okay? That's how you get those middle points. Usually, the one in the middle is easy to get. Okay? Is that so bad? All right. Now, I know that my amplitude is at 2, but since that my A value is negative, do I go up or down first? I go down in this case with the sine value. So remember, your sine function always starts at 0, goes down to the A value, back to 0, to the opposite A value, and back to 0. Okay? That gives me this curve. All right? Now, I know that I'm going to have to shift all of these points, but it's not going to be that bad. So here's my original set of ordered pairs. My original set of ordered pairs is at, well, I'll have a little space here. 0, 0. Next one is at pi over 8 and negative 2. Next one is at pi over 4 and 0. 3 pi over 8 and 2. And then pi over 2 and 0. All I'm doing here is holding you guys accountable for knowing what these values are, instead of putting the little tick marks and your hash marks and things like that and just following through the lines. This, and listing this out, holds you accountable to knowing exactly what the values are. So once again, if you're one of those types of people that like to type things into the calculator and just watch the wavy lines go bye-bye, gotta know that, okay? The x values are always going to be the marks on your x-axis, the critical values. The y values are going to be zeros and a's. Okay? That's your original. Now when you go to do your shift then, I know that each one of these is going to have to get moved right 2 and up 1. Now with our shift here, excuse me, instead of being at 0, I'm going to be at, well, I add 2 to this. So it becomes over at, so here's pi over 2, so let's say here is 2. Okay? Instead of being at pi over 8, it's going to be add 2 to that. 2 and pi over 8. 2 and 1/8. 2 and 1/4. 2 and 3/8. 2 and a half. And just keep pi with it. All you're doing is just changing and moving it that way too. Remember, when you're adding fractions together with a whole number, you just whole number with the fraction and it goes. All right? All right? So then from here, we'll just say it's 2. So 2 and pi over 8. 2 pi over 4. And then 2. And with each of these points, they have to go, was up 1, right? So I know that I have to add another tick mark here. So it's instead of being at 0, it's at 1. Instead of being at negative 2, it's at negative 1. Here it's back to 1, 3, and 1. And here's my new stuff. And then it's just a matter of rewriting out your ordered pairs. So instead of being at, all you're doing is adding 2 to all of these and adding 1 to all of those. So if you're not sure on how to set up these here on the number line, if you will, if you take the original set of ordered pairs and you have to add something to it, just add them in here, okay? And just rewrite it. So it's 2 and pi over 8, 2 and pi over 4, oops, 2 and 3 pi, and 2, and now we're at 1, negative 1, 1, 3, and 1. Okay? And that's what I want you guys to be able to do. You're taking your original values, plotting the parent function, list the ordered pairs really quick, and then go back and relist out your shift. Okay? Now, yeah. Now, what'll happen, let's say the shift was, if the shift was pi over 4, then you'll be able to just put it in here, you know what I mean? But if it's completely off, it'll look kind of weird sometimes. It's not, and remember, I just made this one up off the top of my head. So it might not have been the prettiest thing in the world, because remember, my brain is upset. Okay? So let's look at a cosine one real quick. Let's see if I can get one that makes a little bit of sense. All right, so let's see. Let's try that. So when you're working with cosines, you still go through the same exact sequence of setting up the problem. You still label out your A, your B, your H, and your K. The only difference when you're graphing cosine is where does the cosine function graph start? It starts at the A value. Okay, it starts at the A value. Whether or not the A value could be negative, it could be positive. Okay, it just starts at the A value. Okay. So here, A is 1, B is, H is negative pi over 2. Very good. And K is, so this one's going to move left pi over 2. It's going to go down 3. Okay. So you start out again by going with the parent function. Well, after we label out our amplitude. What's our amplitude?
1.
Good. And your period? 2 pi over 2, which is? Now, since I'm going to be moving it to the left, pi over 2, bless you, I'm going to extend this side a little bit further. Okay? See how I'm extending it more to the left here to give me a little bit of space? Does that make sense? And turn off your phone. I just heard the And since I have to move this one down 3, I might extend this down just a little bit longer. All right, it's one of those things. What's that? Was he? Was it? That's why you just turned beet red. Now, everybody understand why I extend that one down a little bit further? So I mean, eventually we have to shift down 3 points. So I just wanted to I'm just working ahead. So your period is at pi, so that's not, bless you, not that bad. Now when you break that into the breakpoints, that should be the easiest one you can get. Pi over 2, pi over 4, and 3 pi over 4. Okay? Does everybody agree with those breakpoints? Now, the A value is 1. Cosine always starts at the A value. So I start at A, go to 0, opposite of A, back to 0, and A. So my original set of ordered pairs for this one, I'll put them off the side here, I'm at 0 and 1, pi over 4 and 0, pi over 2, negative 1, 3 pi over 4 and 0, and back at pi and 1. Those are all the ordered pairs for the parent function. Okay? I know this is a newer step. I haven't been asking you guys to do that, but I want you guys to get in the habit of doing this because now when you do your shifting, it might be easier with the fractions. So since we're dealing with fractions at all in terms of pi, remember, you don't have to use like longhand multiplication or division here. In your calculators, if you type in alpha y equals, you can get a fraction bar right away. And what I'm going to do is, let's say I need to figure out where this one goes. I know that at 0, if I move it to the left, it's going to be at negative pi over 2. That one's easy. When I move this one, because this will be my last point all the way up here. When I move this one, it's basically 1/4. Then I'm going to subtract alpha y equals 1/2. And it tells me it's negative 1/4. So if you're having problems converting your fractions back and forth, use the calculator. Remember, everything has pi in it, so as long as you keep pi in your numerator, you're going to be fine. So this point comes over to become negative pi over 4. The next one is easy. It's at 0. The next one's easy. It's at pi over 4. Everybody agree with me on that? I should do this in a separate color. Let me change the colors for these. And then this one comes over here. And then the last one comes over to pi over 2. So now, this goes left 2, and then it goes, excuse me, left pi over 2, and it goes down 3. So here's 1, 2, 3. So it's now here. This one goes left pi over 2 and down 3. Left, down 3. Left, down 3. And left, down 3. Obviously, the scale isn't perfect. But what you can see here with the ordered pairs, even if this looks god-awful, which we all agree it looks pretty bad, what you can do, though, is take the ordered pairs and just change them. So instead of being at 0 and 1, I'm at negative pi over 2 and negative 2. Instead of being at pi over 4 and 0, I'm at negative pi over 4 and negative 3. Instead of being, and so on and so forth. Now I'm at 0 and, what was it, negative 2 again? Oh, no, it's not, negative 4, excuse me. And then it was at pi over 2, negative 3, and I skipped one. I did skip one, I'm sorry. This was pi over 4. And then the last one is pi over 2 at negative 2. So if worse comes to worse, if you take the original set of ordered pairs, all you're doing is converting these with your h and your k. You're adding or subtracting the h value to the x coordinate, or you're adding and subtracting the y value, or the k value to the y coordinate. All right? That's sines and cosines. Okay? All right. Now, the last bit that we started to get into yesterday, or Friday before break, was the tangent stuff. So I want to go back and just revisit a quick couple of questions with tangent. I don't think I'm going to do anything with the shift today on tangent. We'll build into that again tomorrow. So for those of you guys, I think most of you guys were here last Friday. If you weren't around, let me show you something new with tangent. I think we started with like that, correct? A tangent b of x, I believe. I gave you guys h and k though, right? We talked about it, but I don't think we did anything. Okay, so the only thing that changes now is that when you're dealing with tangent, your period is going to be different. The A value has a different meaning when you're dealing with tangents. And I'll show you that here in a second. The period of tangent function is always going to be pi over the absolute value of B. If you remember, when you're looking at the unit circle, when you're on the x and y axes, we had the ordered pairs there, ones and zeros, 0, 1, -1, 0, and so on. And tangent was always sine over cosine. It was y over x. Here was 1, 0, and 1. And this was at 0, -1. I can't find the tangent here or here because it's undefined. When you have an undefined thing on a graph, what's usually graphed is what's called an asymptote. These asymptotes for the tangent function occur at pi intervals, because the distance from here to here is 1 pi. Do you agree? So going from x-axis to x-axis, it works like a lot. It's distance. So that's why we get these what are called asymptotes. These asymptotes occur at pi over 2b intervals. Okay? And we talked a little bit about that, how you break that apart. And I'll show you guys how this all works again, because like I said, tangents, I just want to talk a little bit about the generic and how the ordered pairs work out. To be honest with you, I think there's less work with tangent. It's just a little bit weirder to start with. So let's look at an example of a tangent one. I want to make sure I get one that works cleanly to start with. So let's say we have y equals 2 tangent of 4x. I'm not putting any h or any k's in this values yet. I'm not worried about shifting. I'm just going to do parent function tangent. So once again, what I want to do is my a is 2, my b is 4, which means my period is going to be pi over 4. Okay? That's basically how long it takes the tangent function to cycle. So when you go to graph tangent, tangent always goes through the origin. Okay. It's always going to go through the origin at the parent function. If the a value is positive, it means it's moving from left to right like this. It's going to be going like this. If a is positive. If a is negative, it's going like this. Now we got to put in the asymptotes. My asymptotes, in order to have a period of pi over 4, what I need to do is figure out a way to make this distance, pi over 2, excuse me, pi over 4. Well, what's half of a 4? An 8. So if I go out here and out here, if this is pi over 8 negative, and this is positive pi over 8, what's the distance between those two? It's a 4. That's where I come up with the asymptotes. Notice, all I did is I took the period and I multiplied it by a half. That gives me my asymptotes. Okay. Now, the a value is 2, which means there's going to be a point of a positive a and a point at a negative a. What happens here is that this tangent function, when it shifts like that, this is always the origin, and these other 2 points is where the curve is changing directions, it occurs halfway between the asymptote and the origin on both sides. So once again, you have to figure out the halfway point between 0 and an 8. So what's half of an 8? 16. Good. So this is at pi over 16. Oops. And this is negative pi over 16. All right? Notice I'm just breaking things in half. A value, again, is 2. So it occurs here, 0, 0, and here. And I'm not worried about shifts right now, so this can be a solid line. And that's a tangent function. What's that? You gotta be a little louder. These two talk so much. So in this case here, my ordered pairs would be pi over 16, comma, negative 2, 0, 0, pi over 16, positive 2, and my asymptotes are at x equals negative pi over 8 and positive pi over 8. Remember, x equals a number. Yes, it is vertical. X equals a number is always a vertical line, and your asymptotes, when you draw them on your graph, will always be dotted. Okay? And that's what a tangent function looks like. Once again, if you start to remember to get your asymptotes, just multiply this by 1/2, and that'll give you your asymptotes. And put a plus minus on it. Okay. Not so scary? Let's try another tangent one then. Again, I don't want to give you anything too bad. All right, let's say it's 3 tangent of 1/4 x. Once again, you identify your A value here is how much? Your B value is. So that means your period is going to be pi divided by 1/4. What's your period? 4. So your period is at 4 pi. Where are your asymptotes then? 2 pi and negative 2 pi. Excellent. What's halfway between 0 and 2 pi? I know. And then your A value is at 3. Is A positive or negative? So it's going to be moving from right to left, going down and left to up and right. I don't know how to say that correctly. Going from here. And once again, since we are not doing any shifting with this yet, you can draw these as a solid line. And to keep you honest, negative pi, negative 3, 0, 0, pi, 3, asymptotes, x equals plus or minus 2 pi. Now, depending upon what the shift may come tomorrow, you might not get identical valued asymptotes on either side. You might have to actually write down. One of them could be at pi over 2, the other one could be at negative 3 pi over 2, depending on what the shifts are. Okay. Are we frightened to death, or are we okay with graphing the functions for right now? Okay? All right. So what I want to do then What I want to do then real quick is give you guys a couple of problems to work on with graphing and stuff, and then we'll get into more of the shifting of the tangent tomorrow. Review all this stuff up Wednesday and call it a chapter on the graphing part Thursday. All right, let's see here. Pause this right now. Let's do those, 7 graphs? There's two, the 14.1 are the 2 tangent functions. And these guys, these last 5 are sine cosines with shifts. Okay? Tomorrow we will do the tangent stuff with shifts, which you'll find isn't that bad. It's just a matter of not drawing your graphs so small on paper that you run out of space to put your new ordered pairs in.